Okay. But don't do that to me. Okay. Son of a thing. Fix that one more try. Because it's just this cable. Those of you watching the video, this must be fascinating. No, I just got to take this.
Well, someone could just always hold it.
No,
Dave is currently juggling fire.
Yeah, I have many skills. Son of a thing that I won't say. Wow, I was going to say something way worse than bitch, by the way. All right. Well, you know, it's this, as long as the color's consistent, it's got a pinkish hue, as George Costanza would say. Well, so start this. It's different. Yeah, as long as it's consistent, I don't care. If it changes, is the problem. So today I want to talk about something called hierarchical analysis of variance. It's got a lot of other names too. I like the name hierarchical because it's pretty descriptive. There's also something that's called a split plot. Usually all of our factors, our independent variables, are crossed with each other. Every level of A occurs with every level of B. Right? It's getting purpler. Whoa, now it's back. That's good. Each level of A occurs with each level of B, for example. Just like the example we just had in the quiz. Every level of A occurred with every level of B. Every time I turn my head, I think, does it change color again? No. Okay. So I'm not talking about subjects. Subjects are often nested. Whenever we have between subjects, subjects are nested within something else. Within A-B combinations, like in our quiz, or within B, within A, within C, I don't know, whatever. Right? Sometimes, though, things aren't always as they seem. Sometimes things are a little bit different. So, this is a real example. I was telling you the other day that one of the ways you can make a little bit of money in graduate school if you're good at statistics is actually rent yourself out as a consultant. And a friend of mine analyzed this experiment, which was done in Toronto in the mid-1980s, late 1980s. And we have 3 hospitals in Toronto, and we have 6 different drugs that are specifically designed for pain patients, for burn survivors. Okay? The drugs are nested within hospitals. So you have 2 drugs in hospital 1, 2 different drugs in hospital 2, and 2 altogether different drugs again in hospital 3. Why would we do this? Well, it's a matter of a few reasons, a few practical reasons. There wouldn't be enough subjects kind of happily. Well, happily, there aren't as many people that have horrible burns, I guess, put it that way. So you wouldn't have enough subjects, basically. Also, it's a matter of resources, right? Running these kind of clinical trials is difficult to run, so you wouldn't want to do it you probably couldn't do it at one hospital, okay? Because they can't take over the whole hospital doing this. You would have a small number of people in each place. So there were 5 burn survivors in each group in this experiment. 5 burn survivors in each group. Different burn survivors in hospital 1, drug 1, hospital 1, drug 2. Hospital 2, drug 3, that's 5 different people. Hospital 2, drug 4 is different people. Okay? And you might say, why don't we just ignore the hospital and just treat it as, just ignore it and just do a simple one-way analysis of variance of drug, because different hospitals are different, right? Every hospital is somewhat different nursing staff, different set of MDs, right? Different food. There's all kinds of possible things that could be variance we'd want to remove from the model. Yeah.
So if we're doing different hospitals because they might have different methods, why aren't we also doing like different shifts?
Oh, that would probably make the whole thing impossible.
Okay.
Yeah, and you make a point though.
So
yeah. Well, I mean, at some level, you're making a decent point. The thing is that within these people are long-term patients in these facilities.
Oh, okay.
So they're not just getting one day.
Right.
This is 3-4 months of the course of these drugs. Yeah. But yeah, those kind of variables would be things you would want to be concerned about if it was a shorter-term thing. Yeah. So this is a little bit different, the way this is set up, because we've got hospital and drug within hospital, and we test both of those using a subjects by subjects within drug hospital interaction error term. So we list hospital, and that's the final part of Yates order, between subjects within. If there's anything hierarchical, the top of the hierarchy always goes first, between subjects within. So the top of the hierarchy is H, hospital. It has H minus 1 or 2 degrees of freedom. There are 3 hospitals. Drug within hospital, D minus 1 times H. Now within each hospital, there are 2 drugs. So 1, D minus 1, times 3 hospitals is 3 degrees of freedom. Subjects within drug hospital interactions, 4, so N minus 1 is 4, times, there are 3 hospitals, it's 12, and then within each, you're going to think of this within the hierarchy, within each hospital there are 2 drugs. So 4 times 3 times 2 is 20. Yep.
How do you tell hospitals are at the top of the hierarchy?
Because they, I can't pull this back up, but what I can do is draw it up here.
Is it just because the design was drawn like that?
There's no other way you can draw that design.
Okay.
There really isn't, right? So let's just. So we've got hospital 1, hospital 2, hospital 3, drug 1, drug 2, drug 3, drug 4, drug 5, 6. We can't talk about drugs without talking about hospitals, right?
Oh, okay.
But we can talk about hospitals without talking about drugs. That's what culture is. It's a higher level of hierarchy. We can't talk about hospitals. We can't talk about drugs without talking about hospitals. We can talk about hospitals or drugs without. We can't talk about drugs without talking about hospitals. However, we can talk about hospitals without talking about drugs, because different drugs are within each hospital. So this was the case. This is one of those cases I told you the other day about the case when I was doing some work and they had a bad design and I had to tell them they didn't know what they were doing. My friend Todd had to tell these people, they wanted to do a one-way analysis of variance. And he said, you can't. You have to take the variance through the hospitals into account, and the problem is now we have this really weird design. Because when you get a result, and they did get a significant result for drugs within hospitals, it doesn't say that drugs are different, it says drugs within each hospital are different. Right? Because that's what the mean square is. Mean square for drugs within hospital. It's not mean square for drugs. So it makes interpretation quite a bit more difficult. But in this case, and this happens a lot in field sort of work, clinical trials, these kind of things, you have no choice, you have to do it. And of course the best answer is do it again. The problem is these things are exceedingly expensive. Getting subjects is hard. Getting hospitals to sign on to do clinical trials is hard. Okay. But there are cases where this is useful. We have to think about this. And in this case, we really do want to remove the variance due to hospitals. And it would be, I think, disingenuous to ignore it. We could ignore it, but I just don't think that's fair. Yeah, Winnie.
What number did you use for n minus 1?
5 subjects per group, so 4. Another way. The chair that I used to fix the projector.
I'll go home.
Well, anywhere. Do you think at Queens they have ladders ready to fix projectors? Or the professors just float up on their own egos? I'll be here all week.
At Brock, they would just call, like, there's a phone in every room.
There's a phone here too, and I could have called down to the ITS help desk, and they would still not be here because those guys are overworked.
No, I was gonna say at Brock, like, they would always just come in within 2 minutes. It's crazy. There's like 20 of them working all over campus.
Yeah, that's actually 20 is probably not that difficult here.
Really?
Well, no, percentage-wise,
Oh.
right? Because how many students at Brock?
18,000.
Okay, and we've got about let's say we got 1,800. So it makes the math easy. So that means 2 is the same as 20.
True.
Right? And we have less space to cover. Either way, I knew what it was, so I fixed it. All right. Here's another example. We got n equals 3. Now, I don't even know what these are anymore. We got A1 and A2, B1, B2, B3, B4, and C1, C. Oh, look at that. It's a 2 by 2 by 2, but with nesting and repeatedness. There's repeatedness in here. These are kind of questions on exams. Because I can test a lot of different things here. Test a lot of different things. Okay, so let's move that over. Now we have nesting as well as a within subject variable. Yates' order is your friend, everything will be fine. Order is not one word. Looks like a Latvian name. Yates' order is the place for those sabers. Glad I hope you got that. Okay, look at this. Before looking at the next slide, if you have it, that's fine, but before looking at it, what are the within subject factors? What are the between subject factors? C's between? You think so? No, C's within. Is that what you're saying?
Yeah.
Yeah, okay, good. So C's within, everybody gets every level of C. So how do you know that? Every subject gets every level of C. Okay. Between subjects,
A and B.
A and B both are, right? Because different subjects get A1 than get A2. A1, group 1 and group 2 get A1. Group 3 and group 4 get A2. B is also between subjects. B is nested within A. Right? Because different subjects get B1, B2, B3, B4.
So
Okay.
is B nested within A, and then subjects are nested in AB?
Yep. Well done. Yeah, B's within A. Look, because different levels of B occur within different levels of A. B1 and 2 occur within A1. B3 and 4 occur within A2. Okay? We're going to do this the same way we do it with subjects. We're just going to do it with variables now, that's all. That's where it's going to be different, but it's the same principle. It's exactly the same principle. We treat subjects as a variable in these things, so what's the difference? All right. Other questions before I go and show you the source of variation degrees of freedom table? So again, A is within B, or sorry, B is within A. Subjects are within AB, because they're within AB combinations, aren't they? Group 3 is in A2B3. Group 4 is in A2B4. Right? Group 2 is within A1B2, and Group 1 is within A1B1. Subjects cannot be nested within A, nested within B. It doesn't work that way. Okay? And it's partly because, think about it, to the subject's view of the world, they look up and see, I'm in A1B1. They can't look over here. They just can look up or across. They can see what variables, but they can't see what the other subjects are. I'm within A1B1. Okay? It's like what?
Sims.
Okay. I want to think of it like The Sims. Whatever helps you, I'm okay with. Right? Listen, you do what you do. So, I've seen The Sims. I've never played it. I've not played. I played SimCity. I played SimCity a great deal.
I have SimCity on my phone.
I had the original SimCity on my Commodore Amiga, a computer that most of you have never heard of, I imagine.
I was just going to ask.
Sounds like French.
No, it's actually Amiga, so it's actually Spanish. Friend. Yeah.
Your computer friend.
It was an amazing computer. It was it could run its own software, Mac software, and PC software. It was amazing, but no one bought them. I had 3 of them. No one else bought them. Okay. Let's take a look. Start out between subjects within. Remember, A's in between, B's in between, C's in within. So we're going to spend on top of the hierarchy, the most general thing. We can talk about A without talking about B. Refer back to the design. We cannot talk about B while talking about A. Without talking about A. So let's start with A. That's easy. There are 2 levels of A. So A minus 1, so that's going to be 1. That's an easy one. Now, B within A. B minus 1 times A. There are 2 levels. Within each level of A, there are 2 levels of B. 1, so that's B minus 1 is 1 times 2 is 2. S within AB. Subjects are within AB combinations. They look up and they see AB. N minus 1. How many subjects did I say? 5, did I? Yeah. 3. Okay. So that's 2 times 2 levels of A times 2 levels of B. There are 2 levels of B within each level of A. That's what you're talking about there.
2 times 2 times 2.
It is 8. Spencer.
So the N is just how many subjects are in like one group?
Yeah.
Okay.
One cell.
Right.
Yeah. In each cell.
Not the number of all the subjects that are in AB.
That's big. No.
Right, okay.
I always confuse.
Yeah. It's the number of subjects per cell.
They could have just used a different variable.
So does it get all crazy when there's like different numbers of subjects for different cells?
We will talk about that on Tuesday.
Okay.
Spoiler! The world's like that now, eh? You see Game of Thrones last night? A spoiler! That's not a spoiler. The show was on. People know that. It's when you say, remember that part where everybody was killed? That's a spoiler.
I don't even watch any of those.
Or when people get mad at you for spoilers for movies that are 30 years old.
I was going to see that.
No, you weren't. What are the chances?
Later.
Yeah. You know, like an Independence Day. Hey, I haven't seen that yet. It came out in 1996. Stop it.
Yeah, but I couldn't watch it then because I was only 2.
Yeah, well, you know what? I don't care. I mean, you've had all this time to catch up to pop culture. Just make time and do it. It always bugged me. So my friend is, he's more of an acquaintance. It does, no, he's more of an acquaintance than a friend. I haven't really met him in person. That does internet cartoons. And one of the ones he did was just single panel things usually. And one of them was a guy saying, hey, last night did you watch? And the other guy yells, hey, spoiler! And that's basically what the world is sad. So, back to analysis of variance. I do this kind of to keep it fresh and exciting. So C is a little easier because it's not nested or anything. It's the same as we're used to. Or as the talking heads would have said, same as it ever was. So C minus 1, that was just for me. 2 levels of C minus 1 is 1. Now, C by A, C by B within A, C by S within AB. We're done. How do you know what to test with what? You test A with subjects within AB. It's the same rule. You take the thing you're interested in, and you look down until you find it and subjects. There it is. Then we do the same thing here. So this, C by C with C and C by S within AB. CA, C by S within AB. C by B within A, C by S within AB. Add them up just to be sure. 1 and 2 is 3, and 8 is 11. 12, 13, 14, 15, and 8, 23, 24 observations. Got it. Right? Chance of the degrees of freedom coming out correctly, and you having done this wrong, it could happen, but it's slim. All right. Questions? Okay. You should be able to go the other way. So in this one we got B has 2 degrees of freedom, S within B, subjects within B has 9. And this, of course, you do this in the quiz. A has 2 degrees of freedom. B by A has 4. A by S within B has 18. Total 35. So let's figure this out. Let's figure this out. Just like you did on the quiz, except this is a little bit different than on the quiz. Okay. How many levels does B have?
3.
How many levels does A have?
3. Oh, sorry, I was looking at it.
Yeah, they both have 3. So we know it's a we know it's a 3 by 3 because if we take a look, B and A aren't nested with each other or anything like that. So 3 by 3, they're crossed with each other. Because we have, Sarah, if you got to look and see, do we have an interaction term with those two things? And we do. We know then they're not nested with each other. Okay. Okay. Between, what are the between factors, if any? Why?
So it's first.
Yeah, that's one way to say it, because you know I would put this in Yates order. What's another reason? Subjects are within B. Subjects have to be within, between subject factors. So both those are correct. And then A's are within. So we got a 3 by 3. B1, B2, B3. And we have subjects within B, which means how many groups do we actually have? How many groups do we actually have here? How many groups, different groups of subjects do we have? 3. Yeah. Because we have 3 levels of B and they're within B. So group 1, group 1, group 1, 2, 2, 2, 3, group 3, and group 3. So B1 has all the G1s, B2 has all the G2s, B3 has all the G3s. The only thing left is to say how many subjects we have per group. What's our little n? What's our little n? Well, there's 2 ways to do this. There's the hard way and the easy way. But they're both correct. Well, for me, the hard way and the easy way. You may be exactly the opposite for you. For me, the easy way is to go 35. How many observations do we have in the whole experiment?
36.
How many cells do we have? 9. How was 36 divided by 9?
4.
Thank you. Done. That's the easy way. A little bit harder, but it's nice if you check your work. So you can get to this 2 different ways. Oh, subjects within B. So subjects within B equals 9. That means n minus 1 times B equals 9. That means, let's see. Oh, we know what B is. B is 3. So 3n minus 3 equals 9. 3n equals 12. N equals 4. Remember doing that? Remember algebra? Grade 7? Long time ago, but you did it. But the nice thing is you can check it. You can do it, like I said, the quick and easy way. You go with 12 divided by 9, 4. Or you can do it this way. They both go to the same number. Again, it's unlikely if both those solutions are the same that you did it incorrectly. It's possible. Okay.
Dave,
Yep.
so if A and B were both within, then you couldn't just have 3 groups.
If A and B were both within, it would be the same group. Group 1, group 1, group 1, group 1, group 1, group 1, group 1. Group 1. Yeah. If they're both within, right? That would mean if they're both within, we'd have we have subjects subjects A by S, B by S, B by A by S. And we'd be done.
And then between you'd have to have G1.
Well, you'd have none. Between, if they were all between, they'd all be, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right. Yep, exactly. Exactly. So when you're using Yates order, you can figure out in design, you can figure out the error terms. Which is really an important skill. Like I said, it allows you to make sure that stuff that comes out of the computer is actually the correct analysis for your design. It also allows you, when you're reading something, to make sure people actually did it properly. I'm reviewing a paper right now, and the first thing I do, I think I told you this the other day, the first thing I do is I pull out the result, after I read the abstract, is I pull the results section, or the method section out, have it explained to me, and I draw the design out. Actually, if I can't draw the design out, I criticize the method section, because it's like, I should be able to draw this out for myself. Here's a question. Is hospital a fixed factor or a random factor? I guess we'd like to think it's like subjects that we've randomly chosen kind of hospitals. So they're kind of a random fact. However, I could make the argument to you that no, they aren't, and just as convincingly, which is not very much. My advice to you is to avoid such designs like you're avoiding people that have the plague and Ebola. And they've also, I don't know, and other horrible, also perhaps they're maybe flesh-eating disease at the same time. All those things at once, C. difficile. They've got all that at once. These are really no fun. This is why you want to be very careful with your design. And it can creep up on you. It can happen to a friend of mine in undergrad. You know, he was doing human cognition stuff. I was doing like animal cognition stuff and buddies. So everything's fine and blah, blah, blah. We're doing our work and all this stuff. And then he goes to analyze his data. And he couldn't figure out, the computer was confused. Computers usually don't like nested designs. There are ways with SPSS, there are ways with SAS, but it's hard. You have to read all kinds of use all of these advanced commands. So my friend John goes to do this, goes to analyze his data, and he takes it to one of the graduate students in his lab, and he shows it to him, he says, oh man, you've got nested factors. And John said, I don't even know what that means. And he said, well, you've got two groups here, or sorry, two levels of a factor here. You've got two within this one and two within that one. We actually can't tell if B has any effect. We can just say if B has an effect within A. And of course, John just, was upset. He did fine. Everything's fine. But you have to be careful because it's easy to mistakenly design experiments like this. On the other hand, it does sometimes make sense to include nesting in a design. When I've looked at rate of learning in experiments, so I've looked at like over time, and I have blocks of 5 trials. Or blocks of 5 days, sorry. So I graph it up by block. Day 1, block 1, block 2, block 3. Block 1 has 5 days in it. Block 2 has 5 more days in it. Sessions are nested within blocks in that case. And I actually analyze it. And I analyze it that way just to see if there's going to be an effective session. I don't really care about it, but it's to take variance out that I know I can explain. And I have had trouble in the past explaining that to people. Well, why didn't you talk about this? Because it doesn't matter. I'm just trying to explain variance so I can make the error term smaller within I talk about it. So this can show up. It's something you don't want to show up as nested design, if you can avoid it at all. Right? But it does happen. You will have nested factors now and then. The drug within hospital examples are, I think, the best real world example I can think of. And I know that when my friend Todd, when he actually analyzed those data, he told those guys, this is the only way you can do this. You can't ignore the effect of the hospitals. But like I said, is hospital a random factor or a fixed factor? I'm not sure. I think it's probably a random factor. But if it's a random factor, then what do we test it with? Oh, I don't know. Then we would test it with the drug within hospital interaction. Oh, jeez. What a nightmare. This is one of those cases now where you suddenly need to get an advanced stats book and go to the back of the book and find the part about how to derive expected values of mean squares. Jack.
For this week here.
Mm-hmm. For which?
What is B equal to 2 when there's 4 levels of B?
For the example we had today. Yeah, because there are 4 levels of B, but there are 2 within each level of A.
Oh.
Yeah, just like with subjects, right? That'd be like saying, like if we have n-1, let's say we have 2 cells. So we'd say, and let's say we have 10 people. We don't say, well, why isn't n 20? Well, no, n's 10, because there are 10 within each cell. Subjects are just nested in that case. In this case, B is nested within A. Same kind of thing. Other questions about this? Is this making some sense to you? Okay, and practically, I hope you can see that. I mean, the one practical example I can think of literally is the one with drugs in the hospital, and that really happened. That's, I swear. I swear to Darwin that happened. Any questions at all about this stuff? Okay, we can stop.